So now I'm going to actually build my first digital circuit, the really interesting ones, the ones that do practical stuff. And so I have here an assignment for the basic monostable. That's the wrong thing to do. Let's go to instructions. Okay, so the basic monostable is shown right here in this screenshot. So I've got this 555 timer. It's a little bit elaborate, the setup. It's got a push button involved here, a 4.7K resistor. It's got a 1 mega ohm resistor, a 10 microfarad capacitor and a 10 nanofarad capacitor. I may have to mess with those capacitor values a little bit, I think, in order to get this thing to work exactly the way that I want. I've got a 5-volt supply. That's not a surprise. All ICs like this run between 5 and 0 volts. I've got a 220 ohm resistor in my LED. So I'm going to go over to Tinkercad where I have to prototype this. And you see I've already done a bit of work just to speed things along. I have my power supply here, which is set to 5 volts. And I've connected that to 5 volts here on the plus side and the negative side. And I've connected the positive on one side of the board to the positive on the other side of the board and the negative to the negative so that I have power and ground all around. It's going to help me keep my circuit really well organized. I've got my switch here and I've put in the 555 timer. Also, this is the power pin on the 555 timer. You see that I've already connected it to the positive voltage. And over here, this is the ground of the timer, and I've already grounded the timer. So I'm ready to go and build this thing up and see if I can get a positive result out of it. I am going to do what I usually do, and I'm going to work from the input side to the output side. So first thing I'm going to do is I'm going to have a 4.7K resistor connected to 5 volts and a button that's connected to ground. What this means is when I run this circuit, the trigger is going to be at 5 volts. By pressing the button, I'm going to bring it down to 0 because the timer is triggered when the voltage drops. That's what actually triggers the thing. We saw that in the demonstration of this in the assignment. So I have my push button here, and what I need to understand about these push buttons and how they work, it takes a little bit of investigation, is the left-hand side here and here are connected together. They're actually electrically connected, and so it's all one big side of the switch. And on the right-hand side, these are all electrically connected together. So what I've done is here on the left-hand side of the switch, I've connected it to ground. Here on the right-hand side of the switch, I'm going to use this, I think this is 4.7, is 4.7K resistor, which is what my diagram calls for, and I'm going to connect it to 5 volts. So one side of the switch is connected to ground, the other side of the switch is connected through a 4.7K resistor to plus 5 volts, and you'll see that's what I have. I have a 4.7K resistor that goes to 5 volts, and I've got the switch where the other side of the switch goes to ground. Now, pushing this switch is what triggers the timer. So I need to connect my switch to the trigger. So on the low side of the switch, I'm going to run a wire from, where should I put it? I think I'll put it from here over to the trigger terminal. That's the output. There's the trigger. So I'm running it to the trigger terminal on the timer. So now when I first turn this thing on, my timer's trigger is going to be at 5 volts, and when I push the button, it will drop to 0 volts, and that's what will trigger the effect of the timer. So very quickly, I've got my whole input side done here. Now I have to work out all of this nonsense with my mega ohm resistor that comes from the 5 volts and goes to both of these terminals, the discharge and the threshold terminals. I just now finally remembered the word discharge that I was trying to remember in the video before. The discharge and the threshold terminals get their 5 volts through a 1 mega ohm resistor. So I'll look for them on my 555 timer here, and I find that there's the discharge and there's the threshold. Discharge and threshold. discharge, and threshold. Notice that both discharge and threshold are connected one to the other. I'm going to do that in a sort of a clever way here. I'm just going to put in a wire that goes from there to there. Now the discharge and the threshold are connected, and all I have to do is connect them to plus 5 volts through a 1 mega ohm resistor. I have a 1 mega ohm resistor here, so I'm just going to try to pick that up and move it into place there from 5 volts on this end to the discharge terminal. And because the discharge terminal is connected to the threshold terminal, I'm ready to go there. So I have 5 volts to the through the 1 mega ohm resistor to the discharge to the threshold. Now from the threshold, I'm going to go through a 10 microfarad capacitor. So I have these two capacitors here. What's this one? This is 10 micro, and this one is 5 micro. Well, I'll just build this thing to spec. I'm going to have to change that. So this is 10 microfarads right here. And notice it's got this stripe on here, and I talked about this before. This stripe is the low side. That's the side I'm going to want to connect to ground. So I'm going to imagine I'm going to put it right here, and I'll connect this spot right to ground, and then I'll connect my capacitor to it. Now I can't see the wire, it's hidden behind there, but now this terminal of the capacitor, the negative terminal of the capacitor, is connected to ground. This terminal is going to be connected to the threshold and the discharge right there. So what I effectively have there is I've got this whole path from 5 volts through the 1 mega ohm to the discharge, the threshold, and through this 10 microfarad to ground. And I've got that. The other capacitor is for the control on the timer. And so I'm going to drop that one in. I don't have a lot of space here, so I'm going to similarly put in a ground wire here and drop in this capacitor, which is telling me is, what is the spec on that? That is here 10 nano. I think this might cause me a little bit of trouble. We'll see what happens. So I'm going to make this 10 nanofarads, which I don't know why I had it spec'd wrong to begin with. We'll see what happens. So then that's 10 nano there, and that positive terminal of that is connected to control, which is this control voltage is the last terminal on my timer. So now I'm in really great shape. I've got everything done except for the output. So I need to get my LED plugged in here. The trick about this LED is that's the cathode and that's the anode. Which means this is the positive side and this is the negative side, and it's just in the wrong direction for me. I'm going to go ahead and turn it around, but I'm not wild about that. Yeah, I'm just not wild about that. But that doesn't go well. And I'm going to do it the way that I did it before. I'm going to turn this around like this. It just doesn't make me very happy. Here's my, but then again, I'm never happy. So this is the negative end of my LED. So I'm going to go through the negative end of the LED, and I'm going to go to ground through this resistor. This resistor is 220 ohms. 220 ohms is a typical resistor. You find them all over the place in any electronics kit because you have to limit the amount of current that runs through your LED or your LED will burn out. Theoretically, this red LED can handle a current, if I use a resistor, down to 128 ohms. But it's best to avoid that. At 128 ohms, it's so bright and it'll burn out and ruin the thing. So as a standard, we use 220 ohm resistors here. So now I just have to connect this. This is the weird part. I'm going to cross that to get to the output here. I do realize now that I forgot something here. I've got a pin. I've got the reset pin. Where's that supposed to be connected? Well, just like the power of the chip itself, VCC, which is the power, the reset is supposed to be connected to 5 volts as well. So I'm going to go to this reset pin here, and I'm going to connect that to 5 volts as well. And hopefully, I'm not about to embarrass myself. What am I expecting to happen? Well, this is a simulation of this monostable timer. And what should happen is when I press the switch, the LED should come on for a bit. But after a certain amount of time that depends on the resistor and the capacitor, the 1 mega ohm resistor and the 10 micro capacitor, for a certain amount of time and then go off again. But the thing is that when I hit the start simulation button, sometimes it trips the circuit right then. So we'll see what happens, hopefully, This is not going to be embarrassing. And there you go. And my LED turned on, much to my chagrin. So I'm going to wait for a few seconds to see if the LED will go out again, or fade out. Sometimes, there we go. So the LED went out. And so not all hope is lost for me. It's possible that I push this button and it's going to work out great. So here's my push button. We'll see what happens. Simulation's still running. Push the button. The LED comes on. Now wait. And come on, you. Yeah. So it does exactly what it was supposed to do. That is really, really useful. A circuit that, when triggered by a push button, turns on for a certain specified duration that you can adjust using the resistor or the capacitor, and then turns off and is ready to be re-triggered again. The basic monostable.